Hello everybody. I would like to introduce this video about the Bonferroni test. In a last video I talked about the Bonferroni test, but for the case of equal sample sizes. In this presentation it will be about the unequal sample sizes. This is our question here. We have a one-way ANOVA table, and in this table we simply can conclude that because the value of the F statistic or F calculated is greater than the value of the critical F, so we can simply conclude that there is a significant difference between the means of the groups for the experiment. So we need to determine which two means are significant and which of them are not significant. In the below table, here we have the details for the three groups. We have group 1 and 2 and 3. And if you see, the sample size for each group is not the same. For group 1 it's 10, while for group 2 it's 8, while for group 3 it's 9. And the sum of the observations for all the three groups is already recorded here, and the average has been calculated. For group 1 it is 7.50, for group 2 it's 5.25, while for group 3 the average is 7.11. And regarding the variance, it's already recorded in this table. So what is needed in this question is to conduct the Bonferroni test in order to determine the significance status between the pairs of means for the three groups. The significant level alpha is equal to 0.05. First of all, I have talked in the previous video that Bonferroni test is applicable for both equal and unequal sample sizes. Regarding the formula for Bonferroni critical value for equal sample sizes, it is here, Bonferroni critical value. We calculate or determine the value of T at significant level, alpha star divided by 2, and degree of freedom for the error, multiplied by the root square of 2 MSW divided by N. While in case of different sample sizes, the formula becomes the same value of T, but multiplied by the root square of MSW multiplied by 1 over sub n sub I plus 1 over n sub j. And I and j are the different groups. So these are the two formulas for Bonferroni critical value for both equal and different sample sizes. Regarding the equal sample sizes, it's already presented in a previous video. You can see the link below and you can return back. So I'll talk about the different sample sizes. As you see in the table above, the sample size is not the same. For group 1 we have 10, for group 2 we have 8, while for group 3 we have 9. Regarding the comparison between the Fisher's least significant difference, LSD, and the Bonferroni critical value formulas. They are looks like the same, but the difference is that the value of T. For Fisher LSD, we calculate or determine the value of T at significant level alpha divided by 2 and degree of freedom for the error. Alpha here in this case is the original one, which is in our case it is 0.05. Regarding the Bonferroni critical value formula, the same formula, but the difference is that the value of T is determined at significant level alpha star divided by 2. And alpha star in this case is an adjusted or corrected value of alpha. What is the criteria in order to conclude the significance or non-significance for each pair's mean? Simply, we calculate the absolute difference between each two means in the groups and compare it with the value of the Bonferroni critical value. And simply, if the absolute difference between the two means is greater than the value of the Bonferroni critical value, we conclude that there is a significant difference between the two means, which means that the two means are not the same. And in case that the absolute value of the difference in the two means is less than the Bonferroni critical value, in this case, we conclude that there is no significant difference between the two means, which means that the two means are the same, which means that x bar sub I is the same as x bar sub j. So this is the criteria I will conduct in this presentation. First, let's understand the Bonferroni critical value and its contents. As I have said, the value of T is not the same as the value of T for LSD test. It is determined by knowing what's called alpha star. And alpha star is simply an adjusted or corrected value of the original alpha. How to calculate and to determine the value of alpha star? Simply, this is the formula to determine the value of alpha star, which is used in Bonferroni test. Alpha star, or alpha for Bonferroni, is equal to the original alpha, and in our question it is 0.05 divided by the number of paired difference. How many pairs between the means in the groups we have. And regarding the number of paired differences, it is simply can be calculated by k times k minus 1 divided by 2. And k represent the number of groups. So in our question, the value of k is 3. So simply we can calculate the total pairs. So 3 times 2, which is 6, divided by 2, which is equal to 3. So we have 3 pairs in our questions. So simply we can find the value of alpha star. Regarding the value of the corrected p-value for Bonferroni or alpha star. If the original value of alpha is 0.05 and we have only one pair, which means that simply we have two means only, so the value of alpha is 0.05 divided by 1, which is the same. So there is no change in the value of alpha. While if we have two pairs or two differences, the value of the corrected or adjusted alpha for Bonferroni is equal to 0.05 divided by 2, which is 0.025. As you see, as the number of the pairs becomes more, the value of the alpha star becomes less. And as you know, as the value of the probability becomes less, the value of t becomes great. So as the value of t becomes great, the value for the Bonferroni critical value will increase, which means that this test can be considered as a conservative in the case of the increase of the number of tests. Let's return back to our question. As we have three groups, so we have three pairs of groups means, and simply we can calculate it by the formula, which is k times k minus 1 divided by 2. So k in this case is 3. So 3 times 2 is 6 divided by 2. We have 3. So we have three pairs. The first one is group 1 versus group 2, and the second one is between group 1 and group 3, and the third one and last one is the difference between group 2 and group 3. First, let's determine the absolute difference between each two means in these three pairs. So the absolute difference for the mean for group 1 and group 2 is the absolute value of x1 bar minus x2 bar. x1 bar is 7.50. It is simply in the table above. And for x2 bar, it is 5.25. So the result will be 2.25. So this is the difference between the two means for group 1 and group 2. Regarding for the second group, or for the second pair between group 1 and 3, it is the same absolute value of x1 bar minus x3 bar. This is the mean for the first group, and this is the mean for the third group. So the result will be 0.39. For the last one, which is the difference between the means for group 2 and group 3. For group 2, the mean is 5.25, while for group 3, it is 7.11. So the result is the absolute value of minus 1.86, which is positive 1.86. So this is the first step in order to conclude the significance and non-significance between the groups means. The second process is to determine the value of the Bonferroni critical value. But first of all, let's calculate the adjusted or the corrected value of alpha, which is alpha star. So we need first to calculate the value of alpha star for Bonferroni for the original value of alpha 0.05 and the number of pairs for the groups is equal to 3. So by using the formula, the number of pair differences is k times k minus 1 divided by 2. So it's 6 by 2. So the number of pairs, as we said, are 3. And simply they are here. So now we can substitute for the alpha and the pairs in order to get the value of alpha star for Bonferroni. So the original alpha is 0.05, while number of pairs we have 3. So the value for alpha for Bonferroni test is 0.017. So as you see here, the value of alpha star, which is used in the Bonferroni test, is less than the original value of alpha, which is 0.05. What does this mean? If we check for the value of t for the adjusted alpha, which is alpha star, so 0.0085, we get this value by dividing the value of alpha star, which is 0.017 divided by 2. And the degree of freedom is 24. So if we see the distribution curve in the above, the value of t in this case is 2.56. While for the value of t for alpha equals 0.025 for one tail or 0.05 for two tails, and degree of freedom 24, it is 2.06. It is less. So the value here, 2.56, is greater than the value of 2.06, which means simply that if we calculate the Bonferroni critical value for the value of 2.56, it will be greater than the value of t at the original alpha. So this is the reason why the Bonferroni test is considered as a conservative test. So let's calculate the value of the Bonferroni critical value. This is the original formula for the Bonferroni critical value. First of all, this is the value of t, which is determined by knowing the value of the adjusted alpha, which is alpha star divided by 2, and knowing the degree of freedom for the error. The degree of freedom for the error is simply in the one-way ANOVA table. It is 24. Multiplied by the root square of the mean square within, or mean square for the error, and simply it is inside the one-way ANOVA table, and it is 1.54. Multiplied by the 1 over n sub I plus 1 over n sub j. I and j are the groups, or the three groups we have in our equation. So first, in order to calculate for the value of t, for the adjusted value of alpha, alpha star has been already calculated, and the degree of freedom for the error is 24. So the value of alpha star is 0.017 divided by 2, and the degree of freedom is 24. So we need to calculate or determine the value of t for the probability of 0.0085, and degree of freedom is equal to 24. Of course, we can't find a table to return to it in order to get the value of this t. Why? Because the significant level or the probability here, it is 0.0085. So we can find for, let's say, probability of 0.10 or 0.05 or 0.02 or 0.01. Okay. So in order to get the value of this t, we can simply utilize the Excel by writing this formula inside the Excel program. So you can select any cell inside an Excel sheet and write first equal t inverse. He will ask you about the value of the probability. For one term we have 0.0085. Then he will ask you about the degree of freedom, which is 24. So the result is about 2.56. So this is the formula in order to get the value of the t for degree of freedom 24 and probability of 0.0085. Okay, let's calculate the value of the Bonferroni critical value first for group 1 and group 2. This is the Bonferroni critical value formula regarding the value of t at 0.0085 and degree of freedom 24. It has been calculated yet. Regarding mean square within, it is 1.54. It is inside the one-way ANOVA table. And regarding the n sub I and n sub j, n sub I will be n1 and n sub j will be n2. So simply we can substitute. This is the value of t, and this is the value for the mean square within, and this is the value of n1, as you see here in the table. And regarding the 8, it is the sample size for group number 2. So if you proceed, simply you'll get the value of the Bonferroni critical value to be 1.51. 1.51. This is the value for Bonferroni critical for the difference between group 1 and 2. If the absolute difference between the two means is greater than this value, then we conclude that there is a significant difference between the mean of group 1 and group 2. Let's calculate the second value of the Bonferroni critical value regarding group 1 and group 3. The same technique, the same way. This is the formula for the Bonferroni critical value. The things that will change is that n sub I and n sub j. N sub I will be the sample size for group 1, and regarding n sub j, it will be the sample size for group number 3. So this is the value of the t, and this is the mean square within, and this is the value of the sample size for group 1, and 9 is the sample size for group 3. Again, if we proceed, we get the value of the Bonferroni critical value to be 1.46. And simply we can compare this value for Bonferroni with the absolute difference between the mean for group 1 and group 3. The third comparison and the last one is between group number 2 and group number 3. The same formula, but in this case n sub I will be n2, which is the sample size for group 2, and regarding to the n sub j, it will be the sample size for group 3. So simply we can substitute. This is the value of t. This is the value for the mean square within. This is n2 and this is n3. So if we proceed, we see that the value for Bonferroni is equal to 1.54. So by this we finished all the comparison or all the calculation for the Bonferroni critical value for the 3 pairs. Now simply we can make our conclusion for this question. In the table below, we have 3 pairs. First is group number 1 versus group number 2. The absolute difference between the means for group 1 and 2 has been calculated to be 2.25, and regarding the Bonferroni critical value for group 1 and 2, it's 1.51. So the absolute difference in the two means is greater than the value of 4 than Bonferroni critical value. So we conclude that we have significant difference between the two means, which means that the mean for group 1 is not the same as the mean for group 2. And if we return back to the table to the right, regarding the mean for group 1, it is 7.50, and for group 2, it's 5.25. So simply for the first pair, we conclude that x1 bar is greater than x2 bar, which means that the mean for group 1 is greater than the mean for group 2. Regarding the second pair, which is the pair for group 1 and group 3, the absolute difference between the two means is 0.39, and the value for the Bonferroni critical value for this pair is 1.46. So the absolute difference between the mean is less than the critical value for Bonferroni. So in this case, we don't have any significance between the mean for group 1 and the mean for group 3. In this case, we conclude that the mean for group 1 is the same as the mean for group 3. Or simply we can say that we accept the null hypothesis for this pair, and the null hypothesis states that there is no difference between the two means. Regarding the third and the last pair, which is the pair for group 2 and group 3, the absolute difference is 1.86, and the critical value for this pair for Bonferroni is 1.54. So the absolute difference is greater than the value for Bonferroni critical value. So in this case, we have a significance difference between the two means, which means that the mean for group 2 is not the same as the mean for group 3. Which is bigger? We can return back to the table above. For group 3, we have the 7.11, the mean, while for group it's 5.25. So x3 bar is greater than x2 bar, which means that the mean for group 3 is greater than the mean for group 2. And in this case, we reject the null hypothesis, which states that there is no difference, and we accept the alternative hypothesis, which states that there is a difference between the two means. So this is the conclusion of our question. In this table, we have two significance, and we have one non-significance between the pairs. Thanks a lot. If you have any comment, please write it down. Goodbye.